Alright guys, in this video we're going to actually take a look at a logarithmic model here, and it's less about what this model is doing for us, even though this is actually really kind of a cool application of logarithmic models, but more about just saying, hey, now we've seen a logarithmic model, how does this kind of relate to exponential models, and how are they same and different in how we solve them? So let's go and do this first. We're going to read through it, and what I want you to kind of try to pick through is what are the variables that are being related to one another here. So it says on the Richter scale, the magnitude R of an earthquake of intensity I is given by R equals the log of I over I sub 0, where I sub 0 equals 1 is the minimum intensity used for comparison. So it says find the intensity I of an object or of an earthquake with the following magnitudes R. So first things first, it looks to me like our two, we're actually given the model here. We just hooked up. What we're told though is our two variables are R and I, where R is our magnitude and I is our intensity. And so just like with almost all of our models here, we're going to say that we have I and R, and I'm going to make sure that I put I on the left and R on the right, just because when I look at my model here, it looks like R is the variable that we already have solved for, in other words, our dependent variable, and it really, the magnitude of an earthquake depends upon its intensity I. So looking at this over here, it says find the intensity I of an earthquake with the following magnitudes R. Well, it seems real simple to me. What we're looking at is a situation where we've been given some magnitudes here. What we want to do is determine the intensity. Okay, so looking at our model here, we can just go ahead and plug these values in for R and solve for I. So some things. One, I sub 0 is equal to 1. So in this model here where we have R is equal to the common log or log base 10 of I over I sub 0, we really have I over 1, which means that our model now just kind of becomes this common log of I. It's kind of a straightforward relationship. So if this is our model here, what we're going to do is we're going to plug these values in for R and solve for the intensity. So let's start with, what if I were to plug in a 9.0 on the Richter scale? What would have to be true about our intensity here? So with logarithmic equations, of course, the first thing we check for is, can we write this in a one-to-one form? Can I write this as the log base b of something equals log base b of something else and equate their arguments? In this case, I only have one log. So what we're going to have to do is then isolate the log, which we've already done. We don't have any coefficients here. We don't have any plus or minus anything in the back there. Since this is isolated, what we're going to have to do is use that E word. We're going to exponentiate both sides with a common base. So in this case, because our base on our log is 10, and I didn't have it written in there before, and we don't have to write it, but I'll write it in there just for emphasis, what we'll end up doing is we're going to make both sides exponents, and we're going to exponentiate both sides with a base of 10. That is to say, 10 to the power of 9 has got to be the same thing as 10 to the power of log base 10 of I, because 9 was equal to log base 10 of I in the first place. And so what we end up with here is this. We get just I on the right, and on the left we get 10 to the ninth. And so what I'm going to do is I'm actually going to leave this as 10 to the ninth power, just because that's really 1 with 9 zeros after it, or I suppose 1,000, million, billion. That'd be a billion units of intensity there. So let's go ahead and take a look then at solving this if we had had 7.4 here. If 7.4 had been on our Richter scale, we would have had log base 10 of our intensity over 1. Or in other words, 7.4 is equal to the log of I. And because, again, the log's already isolated, let's go ahead and exponentiate both sides here. And again, we're going to use a base of 10 because we want to take advantage of our inverse property of exponential and logarithmic things. So those would cancel, and we would just get simply 10 to the 7.4 power on the left is equal to I. And this time I'm also going to leave this as 10 to the 7.4 power, but I'm curious to see what that is. And so I want you to see also that 10 to the power of 7.4, this isn't as easy as just it has a certain number of zeros after it. There's actually a number associated with this here. So we have 25118864. So this is approximately 25118864 .32 in magnitude there, or intensity. Okay, so it's just an example of a logarithmic model that was given to us. We want to identify the variables, and when given a known, go find the unknown that we don't know yet. Cheers.